Welcome to qnawire.
Okay, so what we have here is a very standard Newton's second law problem. So we have a box on a frozen pond, and a fisherman is applying a horizontal force. So we'll go ahead and draw that with a blue arrow, and that is being indicated by this vector right here. So in vector form, Newton's second law tells us that the vector F is equal to the mass of an object times the vector form of its acceleration. So in this problem, because we only have one force, therefore we're also going to get an acceleration in a parallel in the same direction, and it's just one directional, so we can go ahead and remove the vector signs because we know that they're pointing the same direction, so that we only have to worry about magnitude. So F is literally equal to mass times acceleration. We're given the force, we're given the acceleration, so we'll just divide through by acceleration on both sides in order to get that mass is equal to F divided by A. Plug in some numbers here, and then because this problem is so simple, we can nicely take a look at how the units work out. So for force, we're told that it's 48.0 newtons. Note that we have three significant figures here. So I'm actually going to write out the Newton in its long form, so it's equivalent to a kilogram multiplied by a meter per second squared. And the way I remember the units for Newton is to literally just remember F equals ma, but that's what it's equal to in SI units, so that we can see how it cancels out with an acceleration of 2.20 meters per second squared are these standard units of acceleration. So in terms of units, we see that we have meters per second squared on both top and bottom, so we can go ahead and cross those out, and we're just left with kilograms on top, which is great because mass is what we're solving for. So plug those two numbers into a calculator, and then you get at the end of the day that we solve for a mass of 21.8 kilograms to three significant figures. Go ahead and put a big box around that. All right, and we're done.